Hello, everyone. Welcome to welcome to the final review. Today we're going to just go over a whole bunch of problems. So I hope you're ready to lock in and figure it out. We're going to be doing all days. Please don't watch this all in one sitting. You should not be doing that. Again, do it by yourself. Figure it out. If you have questions or you're like, I'm stuck, then yes, please do that. Please watch it, but don't watch it from beginning to end. That is not what this video is intended for. All right, we're going over day 1 of 4. This is going to be talking about, is it a function, not a function? That's going to be the next 4 problems. This goes in general groups of 4. It's going to be similar types of problems so you can get some more practice on it. All right, each graph is a relation. Determine if the relation is a function. So the relation being the x and y, there's a relationship there, right? Then determine the domain and range of the graph. Okay, number 1, if you can see here, let's see if I could bring this down just a little bit, just a smidgen. Okay, that's too much. You like this a little bit. Number 1, function, not a function. Okay, so first we're going to see, remember, if it's a graph, we're going to be talking about the vertical line test. And if you notice right here, I tried to make myself a vertical line, and I'm going to be moving this guy. So remember, the vertical line test says that it can only pass the graph, meaning the graph can only pass this green line right here, the vertical line is straight up and down, can only pass it 1 time. If at any point it crosses 2 times, it broke the rule, can't do it, right? Because which means for every x, like when x equals to 5, what is y? Y could either be up here at a 5 or down here at -1, right? So it has 2 different possible outcomes. It's not a function. Even if that happens just once, not a function. Okay, so it happens here several times actually, right? Anywhere around from 4 to 6, it's gonna cross more than once. So this does not pass a vertical line test. I'll just move my vertical line over here to number 2 to get ready for that. And so we're going to say this is not a function. Why? Because it does not pass the vertical line test. I'm not going to ask you that on the final, but it's good to know why. So we're going to talk about domain. I'm going to make a domain this pink color. So domain. Remember, domain is talking about all the x values. So we're looking at this blue line here, what I'm calling the graph, right? This is what we call the graph. And so the blue line, how far left and how far right does it go? So it goes all the way left to this end point right here. So all the way from -2 to over here. Remember, we're not looking at this end, right? This open circle part. We're looking at how far right does this graph go. So it goes all the way up to 6. So again, we're going to start with the smallest number first. So it's going to go from -2 is less than or equal to x, because remember, we're talking about the x values, which is less than or equal to 6. And again, we know that it's equal to because there's no open circle at any of these 2. And notice here, if it's just a line, that's a closed circle because it's all just little points on there, okay? That's basically what a line is, just a bunch of little points. So -2 is less than or equal to x, which is less than or equal to 6. Again, it is always less than, it's not going to be greater than. So that's because we always start with our smallest number. All right, so again, we're going to talk about our y. We'll make that purple. Don't ask why. We're going to be like, how low does this go? This goes all the way down to -6 right here, right? And it goes all the way up to this highest point right here, which is at 6. So if you see right here, so range, that's going to be lowest, remember, is -6. It's going to look exactly like our domain is less than or equal to because it is a closed circle right there. Y, instead of x, we're going to put in y, less than, and if you look right here, it's at 6, it's an open circle, right? It's an open circle, which means it cannot equal 6. It could be anything a little less than 6, it just can't be 6. So that's why we do not have that, what is it called? The line underneath, the equal sign underneath. Okay, there we go, done. So number 2, we got function, not a function. So again, we're going to take our little handy dandy vertical line here, well, mostly vertical line, and we're like, okay, is this a function, not a function? And does it hit more than once at any given time? And And, ooh, did you see right there? It was very quick. Notice right at the very beginning. Notice that's a vertical line in and of itself, right? That from at -7, that's not a function, right? Because right here at -7, when x equals to -7, there's a whole bunch of different y values. Y could be anything from -1 all the way to -5, right? And anything in between that, right? So definitely because of this guy right here, because of that, this cannot be a function. So we would be like, not a function. If it didn't have that part, then the rest of it, yes, definitely totally a function, but it is not a function. So I'm going to write that down. All right, and then we're going to go ahead and do our domain and range. Okay, so regardless of whether it's a function or not a function, you can always do the domain and range, because the domain and range just tells us what are all the possible x values, and the range is what are all the possible y values. That's all it's talking about. I should probably move this guy right here. I'll move this down here. And we go, oh, look, it goes as far as we know right here, -7, and it goes all the way to the right at +7. I'm not going to do that so dark so we can see if it was an open or closed circle there. If you can see right there, yep, it's a closed circle. So we know it's going to be this less than or and equal to for both of them. So we have -7 is our smallest, less than or equal to x, which is also less than or equal to +7. Done. And we're going to talk about our range. Okay, looking at the lowest point, this is the lowest point right here. So we're going to be like, oh, that's -7, all the way up to +6, because that point right there is the highest point. So range, remember, it has nothing to do with the endpoints. Sometimes the endpoints are the highest or the furthest on the right, but it's not always the case. So range is going to go all the way from -7, which is less than or equal to y, which is less than or equal to +6. And again, these are both at parts of the graph where it does not have any open circles, so we're just saying it as less than or equal to. All right, we're on to number 3. So again, we're going to check if it is, did I change to pink? All right, so if we look over here, does it cross this, the blue line cross the pink line, now pink line, more than once at any given point? Nope, it's totally fine, right? So we're calling that a function. So function, yay, we finally found a function. This is what it looks like. Some of you guys may have noticed, I don't know if you can see it, but there is an arrow. So what does that arrow mean? It means it goes on forever and ever in that same direction without turning, just keeps on going on in that same direction again, and like forever, right? That's why there's an arrow, because it does not stop. Not for nothing. Okay, so again, our domain is going to be talking about our x values. So we have all the way to the left, we have here a -6. And then to the right, we have, it doesn't end, right? So if it doesn't end, we can't do anything. So if we were to write it like how we normally would, -6 is less than or equal to x, which is less than, and it doesn't have a boundary, right? So it's just going to positive infinity. Okay, normally we don't need to write this positive infinity because we can just say this. Let me see. So basically this part right here, we're going to flip that, and I'll show you what we're going to do. So instead of x being on the right, we're going to bring x to the left. And I'm doing this because it makes better sense to us, to human beings this way. Most human beings, not everyone. I can't speak for everyone. And then remember, this big part is pointing to the x, is facing the x. So we're going to have it face the x this again. And then -6 is going to be on the other side, right? So when you have that, so we have x is greater than or equal to -6. Greater than looks a little strange. Try that one more time. Okay, that does not look any better. So remember, we're saying that x can be anything that is, as long as it's greater than or equal to -6. Does that include infinity? Yes. That's what we didn't, and the infinity is redundant. We don't need it. Okay, so you're going to see it just like this. If you write it like the above, are you wrong? No. unless you put equal to, because, you know, technically you cannot equal infinity because you can never get there. If you can't get there, you can't equal it. You see what I'm saying? So there we go. So then we're going to talk about the range. So how high and how low. So the range is going to be how low. Oh, this is how low. Do not say 3. A lot of people are going to say 3 because, oh, later, like, oh, look, it's at 3. No, we're talking about the y value. So we're going to be going across to the y-axis and be like, oh, that's 0. And then up high, you would like to say it's 3, but it's actually not 3 because remember we have this arrow side, which means, and it see how it keeps on going up and up and up. So it actually has no cap. No cap. So the lowest point is 0, less than or equal to y, which is less than positive infinity because it's going up to positive infinity. So again, just like how we did for the domain, we can rewrite this. Ooh, I went down too far. Just like that. So we can rewrite this without the infinity, and we could just be like y is greater than or equal to 0. Which makes sense because y it never goes down below the x-axis, right? It never goes negative, right? So y can be anything at 0 or higher. Okay, that's how that goes. All right, so we got the range and we got the domain. Okay, we're done. Okay, on to number 4. If you look at number 4 here, see if I can call up this guy. There we go. He's still going up. Okay, number 4. We're going to do the vertical line test, and some of you guys may see it already. Does it pass the vertical line test? And you'd be like, no, right here. See how it crosses 2 times? Definitely not going to work. All right. So there we go. Definitely not going to be it. So this one, again, is not a function. All right. I guess 3 was our only function. Technically, number 2 was supposed to be a function too, but I didn't. I didn't see that vertical line on the very left. All right, so not a function. We're going to go, that's a secret just for this video. Nobody else knows that. Domain. Let's see here. If we have domain, that's going to be all our x values. Ooh, do you notice here we still have an arrow? I'm going to just continue that arrow. Do you need to do that? No, but it helps me to remember. And how far left does this go? It just keeps on going because notice it's keep on going to the left. It's going down and then to the left, right? So yeah, there's no cap there. But we do have a maximum number, right? It goes as far as 4 right here, right? So it's going to be x is greater than or equal to 4. Here I'm not going to do the other side because we don't need it because actually I don't need it. But I wrote this one. Did you see my mistake? X is greater than or equal to 4. So at 4 and more, no, it's 4 and less, right? It's less than 4. So I should be like, just kidding. And it's going to be x is less than or equal to 4. Ooh, that could have been a big problem. All right, so x is less than or equal to 4. So anything at 4 and less, x can be. All right, we're going to head over to the range here. Range is going to be, okay, we don't have a minimum, again, because it's going down, right? So it doesn't have a lowest number, but it does have a highest number, right? The highest number is at 5. Don't say 7. Remember, it's between the 4 and the 6. So that's at 5. So we know that y is going to be less than 5. Why didn't I not put equal to? Because you see this open hole here? Open circle means not equal to, cannot equal. It's a hole. Like literally, if you were to walk up to the graph and write it at 5, there would be a hole. You would not be able to see inside there. It's a hole. I guess you couldn't see inside because it was a hole. Anyways, there we go. So there's your domain and range. On to number 5. We only have 100 more to go, right? Okay, here we go. We got this. If we take a look at this, we're just solving equations. You got it in algebra. You got to know how to solve equations. So here we go. Here's our n. So we want to isolate n. How do we do that? Oh, do you see this big divide? It's not just for the n, it's also for the 3. We need to get rid of that. Okay, think of it like it's parentheses, right? So how do you get rid of a divide by 22? You're going to have to do the opposite of that. So multiply by 22. Don't forget on both sides. So multiply by 22. And these guys cancel out because 22 divided by 22 is 1. Okay, here we got 22 times 1 is just 22, is equal to, try that equal to again, equal to 3 plus n. All right, and then from here, we're going to just get rid of the 3. Since there's a positive 3, we're going to subtract 3. There we go. And what are we going to have left? 22 minus 3 is going to be 19 is equal to n, right? If you want to rewrite it as n is equal to 19, that's totally fine as well. Either way is okay. All right, number 6. Look, it's kind of similar to number 5, right? So the first step is get rid of this 8 because it's covering both the -6 and the b. So we're going to multiply by 8. Multiply by 8. And what do we get? The 8's cancel out on the left, and we get -6 plus b. Make sure not to get the b and the 6 mixed up. -2 times 8 is going to be -16. All right, last step. We got this -6. We know they're adding with each other, so we're going to be add 6 on both sides, right? Because that's how we make this become -6 becomes 0, right? So that becomes 0. And all we have left is b. So b is equal to -10. Yay. All right, number 7. All right, if you look at number 7, we have parentheses. Okay, there's 2 ways to get rid of this parentheses. One is to distribute. Most people would do that. The other is to divide. You can decide. Usually, though, the only reason why I would do divide first is if 3 goes into 54 evenly, because if not, I'm not dealing with fractions. Okay, I would rather deal with that at the end. So not that I don't like fractions, I'm just saying it's just less work to not deal with the fractions. All right, so let's start with green. So I'm going to just distribute first. So -3 times x is going to be -3x. You know what I forgot to do? I forgot to write the left-hand side. We're not doing anything with this left-hand side, so I'm just going to copy it down because I got to get rid of this parentheses first. And then I have -3 times this -1. So -3 times -1 is +3. All right, now it's just a 2-step equation. We know how to do these. We've done these before. So again, we're going to get rid of our add and subtract first. So we're going to subtract 3 on both sides. And we get -54 minus 3, which is going to be -57. Let me write that with the other color. This can be -57 equals, and all I have left on the right is -3x. All right, and then we're going to get rid of that -3, not the x, just the -3, because remember, we're isolating the x. And here we go. So we get 57 divided by 3, which is going to be, if it was 60, that would be 20. So 19. See how I did that? So x is equal to 19. Done. All right, moving on to number 8. Number 8, okay, so do you see this is different than 5 and 6? I think it was 5 and 6, right? Where the divide is just for the x, so which means I got to get rid of this -10 first. And so what I'm going to do is I'm going to add 10 on both sides. So look at the way it looks. That's going to determine what you're going to get rid of first. So -13 plus 10 is going to be -3. Excuse me. I hope that wasn't too loud. So we got x divided by 3. Again, how do you get rid of a divide by 3? Multiply by 3. Just like that. Good job. And then 3 times -3 is going to be -9 is equal to x. Woo! 2-step equation. First step, add and subtract. Second step, multiply, divide, right? In most cases, unless you have problems that look like number 5, right? But think of those like parentheses. All right, so number 9. Let's go with number 9. Slowly getting there. All right, if you look at number 9, we have variables on both sides. We can't solve it very well like that, so let's get variables on one side, okay? You can decide which way you want to do it. I'm going to add 3n on both sides. Okay, so remember, we're trying to get rid of the whole thing, So we have to add both the 3 and the n, right? That crosses out, and we get -8. -5n plus 3n is going to be -2n. And if you have not, you don't know your math facts, you really need to know how to do them. It would save you so much more time. You would learn it a lot better. Now that we have n on one side, it's back to a two-step equation. So we have, we're going to get rid of the add and subtract. So this is going to be +8. So we're going to add 8 on both sides. And we got, just kidding, -2n is equal to -14 plus 8, which is going to be -6. And then we have a -2 over here. We're not adding it because remember, when there's no operation there, that means it's multiplying. We're going to divide both sides by -2. And then your n is equal, I'm going to just write it over here. So n is equal to 3. All right, moving on. We got m's on both sides. So again, I'm going to put the n's together. So I'm just going to add m on both sides here, plus m. So the m cancel out on the left. And so I'm going to have all of my m's over here. So m plus m is 2m. And I'm just going to add these guys up. So 2 plus 8 is 10. 10 minus 15 is going to be -5. All right? So again, think about how I did that. Try it yourself. If you didn't do that already, do it now. How did I get a -5? Using 2, 8, and -15. Okay, again, now it boils down to a two-step equation. I got this on the m side. I got this -5, so I'm going to add 5 on both sides. And I have 8 is equal to 2m. And how do we get rid of that 2? We're going to divide by 2. And we get 4 is equal to m, or m is equal to 4. All right, number 11. Again, we have r's on both sides. So what we're going to do is we're going to let's get the r's on the left-hand side, right? So I'm going to just subtract 8r here. Subtract 8r here. And you're like, oh, do you see what I see? Literally all of my r's canceled out. Okay, and all I have left is a 4 is equal to a 5. And I don't have any r's, which means only one thing. 4 does not equal 5. This is not a true statement, right? So no matter what r is, there is no solution. So we're literally going to be like, no solution. There is no number that r can be where this will work. Like, it'll never work. Because notice they both have 8r. And if on one side you have, so 8r is equal to 8r, right? So if on one side you add 4 and the other one you add 5, are they going to be the same ever? Never. Okay. So again, so that's just no solution. Done. Don't even have to go any further. Here, I'm going to just get the x's together. Again, x's on both sides, got to get them together. So I'm going to just add 2x on both sides. If you wanted to, you could have just added x on both sides, but I don't want to because I noticed some patterns here. So I got -x plus 2x is going to be just x. If you want to write down 1x, you totally can do that. Okay, and then plus 6 is equal to 1. And then we're just now to a one-step equation, plus 6 minus 6. And we have x is equal to 1 minus 6 is -5. Ba-bam. All right. Ooh, we're getting to slightly more complex things. Excellent. Let's take a look here. We have parentheses. We've got to get rid of that first. Okay, so let me copy down all the things leading up to that point. So I got -126 is equal to 2. And then you're going to be like 8 times 2x is going to be plus 16x. And then the next part is 8 times -4. Because how many 2x minus 4s do we have? We have 8 of them. So we have 2x minus 4 times 2x, or plus 2x minus 4, 2x minus, we have 8 of them. So this is going to be 8 times -4 is going to be -32. All right, so I'm going to just combine like terms here to kind of make things a little bit, looking a little nicer. So I have my 16x first. I always like to put my variable first and then my other numbers. 2 minus 32 is going to be minus 30. All right. Now we're back to a two-step equation. And I'm going to just go like that. Okay. And we're going to, again, add 30 on both sides. And we get negative 126 plus 30 is going to be negative 94. 96. I'll get there. Yes, negative 96 is equal to 16x. All right, trying to do this all in your head is sometimes not easy, but we'll get there. So again, we have 16x is equal to negative 96. So we're going to divide by 16 on both sides. And we get x is equal to negative something. Negative 6. Yep, negative 6. There we go. X is equal to negative 6. Done. All right, number 14. You notice here we have parentheses and nothing much else. So we're just going to distribute that. So 7 times negative 7 is going to be negative 49. Don't forget the k. And we got 7 times negative 5 is going to be negative 35. And that's all equal to negative 231. All right, and then we're going to just add 35. Again, do you see how this always boils down to like a one-step or two-step equation? It literally every single time. Yeah, that's what we do. So it's really, that's why it's like, you got to know your basics because it always leads up to that. Okay, or leads down to that. Anyways, negative 231 plus 35 is going to be 190 something. 196? 196. Okay, let me just make sure I got that. That's going to be, okay. There we go. And then we're going to do our last bit right here, which is going to be divide by negative 49. Divided by negative 49. And we have k is equal to, negative divided by negative is positive, and I know it goes in there 1, 2, 3, 4 times. So it's going to be 4. K is equal to 4. Woohoo! Right, moving on. Negative 15, just 15. Okay, I see parentheses here, so I'm going to just copy down the stuff that I don't need to work on yet, is equal to negative 5x. That has nothing to do with these parentheses, so I'm just copying that down. So I have 7 times 1, which is just plus 7. I have 7 times 6, which is going to be plus 42x. All right, I'm going to combine like terms here because they're both on the same side. They're not on opposite sides. So I'm going to just rewrite it. So negative 289 is equal to negative 5x plus 42x is going to be 37x plus 7. 7 has nothing to add with it, so we leave it like that. Again, it's two-step equation. I'm going to subtract 7 on both sides. And we got negative 296 is equal to 37x. And we're going to just divide by 37. Ooh, you have your calculators. And we're going to get x is equal to 37. It's kind of like 30. So like 1, 2, 3, 4, 5, 6, 7, 8. 8, 7, 8, 9. Okay, I might need to calculate for this one. Because that's, did I subtract that right? 42. Yeah, 37. Huh. Okay, let's go. 296 divided by 37. Oh, did the wrong one. Equations 2. I mean, I'm just drawing a blank. Oh, because it is a fraction. Okay. I did something wrong here. What did you see my mistake? I haven't seen it yet. Okay, 289 and negative 5 plus 7, and that's going to be 42. 42 minus 5x is going to be 37x. And then I'm going to subtract 7 on both sides. And I get 196, 296. Yeah. Okay, I'm gonna just go figure out what this answer is. Okay, remember on the side I have the answer. That was number 15. Ooh, can you guys read upside down? Number 15. Yeah, 19. 15? No, 15. -8. I'm just like, I didn't give you guys any, I mean, not that the answer can't be a fraction, but I'm just like, I know I didn't give it to you like that. I might have to go back to this one. 289. -7, 296, 37. Give me a moment here, please. Okay, you know what I did wrong. I put in the calculator wrong. I'm like, that's why I can't find the error. Huh. Okay, because I said 296 divided by 7 and not 37. Not a good idea. Okay, so anyway, so it should be -8. Ugh. Okay, just making sure. All right, so phew. I'm not going crazy. I'm like, there's no way. I don't even know what I did wrong. All right, so number 16, we're doing the same thing. We got parentheses, so we're just going to distribute that guy out. So -7, I'm going to just change my color. So -7 times n is going to be -7n. And -7 times -4 is going to be positive or plus 28. And that equals 84. Okay. Again, if you wanted to divide that out first, I can show you how it works. Because I do know that 7 does go into 84. It can save you a step, but this is just, if you're not good with number sense, then you just go with your typical usual way. So -7n is equal to 84 minus 28, which is going to be 56. And we're going to divide by -7, both sides. Equals n is equal to -8. Bam. All right, again, I could show you here on the right-hand side. -7 times n minus 4 is equal to 84. And again, we're going to just, I mean, like I said, -7 is multiplying with n minus 4, so I'm going to divide out n -7. All right, and what do we have left? N minus 4 is equal to 7 goes into 84, 10, 11, 12 times. So it'd be -12. And then we're going to just add 4. Do you see how it kind of shortens and makes all the numbers smaller? And then n is equal to -8. Okay, see, same answer. 2 different ways to do it. All right, as long as we're not breaking any mathematical rules, we're good to go. All right, number 17, we got a few more kinds of solving equations problems to go. And again, we got parentheses and we got variables on both sides, all the things. We have -7n, and then we're going to distribute 5 times 1 is going to be +5. This is going to be 5 times -6n is going to be -30n. And what does that equal? It equals 5 minus 3n. Okay. And then if you notice right here, we have like ends on both sides, but also I have these 2 ends on the same side, so I'm going to combine like terms. So -7n minus 30n is going to be -37n plus 5 is equal to 5 minus 3n. All right, I'm going to get all the, variables on. I'm going to bring it to the right now. So I'm going to be like plus 37n plus 37n. That was weird. 5 is equal to 5, and that's going to be plus 34n. Again, if you get stuck on like, how did she get that? Like literally give your brain time to process, pause it, figure it out by yourself, look it over again, look at the explanation again, and then continue on. Don't just be like, oh yeah, That's not going to help you. Again, we're going to, on the side of n, we're going to get rid of the add and subtract first. So we got, oh, did you notice? 5 minus 5, 0. We can still do, if 0 is still a number, we can do something with that. 34n, right? And how do you get rid of the 34? We divide by 34. So you guys may already know the answer here, but we're going to keep on going. So n is equal to, what's 0 divided by 34? Hope you didn't say 34, because it's 0. N is equal to 0. Okay. Again, we're going to just distribute this as number 18. 18, we got, just copying down the things that we don't need to work on yet. And we have negative 5 times n, which is going to be negative 5n. And then we have negative 5 times 3 is going to, ooh, that's overshot that. 3, which is going to be minus 15. And then we're going to get the x's together. We got plus 5n, plus 5n. Oh, look, they both cancel out. Weird. And all we have left is negative 15 is equal to negative 15. And is negative 15 equal to negative 15? Yes, 100%. Which means, remember when we started with negative 5n, both of them equals each other, right? Totally equals each other. If I subtract 15 here and subtract 15 here, are they still equal to each other? Yes, because I subtract the exact same amount from it, right? So this one is, it could be any number. So you'll see all real solutions. The reason why we say real is because there's something called imaginary. You won't get to that, not in Algebra 1, but you'll see it in Algebra 2. So there are real numbers and imaginary numbers. We're looking at the real ones, so that's why we're like, oh, well, they're all real numbers. Ooh, I should see. What did they put on there? All real, oh, my bad. All real numbers. I was thinking of the system of equations where we have infinite many solutions. I don't know why I made that mistake. Sorry, my bad. So all real numbers, because it's all real numbers. All right. Infinitely many solutions. That's for the system of equations. So these are all real numbers. Anything for n will work. You can think of a number, that's going to work. Okay, even if it's a decimal, it will still work. All right, so here we go. Again, parentheses, so we're just going to distribute. So 3 times 1 is going to be 3. 3 times 6, negative 6r is going to be minus 18r. And then the rest of it, I don't need to simplify more, so I'm just going to be like, copy that down. All right, we want to get the r's together. So I notice I have a minus 18r, so I'm going to just add 18r because I want to, work with positive numbers because, I'm positive like that. And we got 3 is equal to negative 4 minus or plus 18 is going to be 14r. Don't forget, I can't forget the plus 31. Oops, almost forgot that. And then now again, it's a two-step equation. So we're going to subtract 31 on both sides, and what are we going to do? 3 minus 31 is going to be negative 28 is equal to 14r. And divide by 14, and we get r is equal to, yes, negative 2. Done. All right, number 20. Ooh, I notice here on the left, I don't have much work to do, but on the right, I have a few things I need to do, or just one thing I need to do. I need to distribute. Negative 2 times 2 is negative 4. And negative 2 times 5 is going to be negative 10x, or minus 10x. All right, nothing to combine like terms on. Since the x's are on both sides, I'm going to just be like, add 10x on both sides. And then I have 17 plus 7x is equal to negative 4. And again, two-step equation, we're going to subtract 17 on both sides. And we get 7x is equal to negative 4 minus 17 is giving me minus or negative 21. And now we're going to divide by 7. And we have x is equal to negative 3. Woohoo! It's like that. Okay, we're done with equations now. Now we're going into inequalities. One variable inequalities. Because you know why it's called one variable inequalities? Because there's only one variable. All right, we're going to treat this just like we did the equations. All right, So if you notice right here, I still have parentheses here. Oh, let me write down the other stuff first. I keep forgetting to do that. So minus 116 is greater than 4 times 8x, which is going to be 32x. 4 times 3 is, which is going to be plus 12. And it's now a two-step inequality. So we're doing the exact same thing as we've done before with an equation. And we're going to, x is on the right, so we're going to get rid of the adding, subtracting stuff. So we're going to subtract 12 on both sides. And we have negative 128 is greater than 32x, right? And we're going to get rid of 32 by dividing by 32. And we get negative 4 is greater than x. I always like to write it where the x on the left-hand side. So if I want to flip everything needs to flip, okay? So I'm going to be like x is on the left, which means there's inequalities. The little side is pointing to the x. So I'm going to continue that and flipping that inequality, putting my negative 4 on the right. If you leave it as this one, that's fine. It's just harder to graph it because you kind of have to think differently than what we're used to thinking. So x is less than negative 4. So at negative 4, can it be negative 4? No, because there's no equal to sign. So it's open. Just like, remember, think about our domain, related, right? And then we're going to be going which way? It says x is less than, so we're going to be like, oh, these are all the numbers that x can be, right? Anything less than negative 4 is going to be a solution. Done. 22. Again, I notice here that I'm going to have to distribute this guy. So 8 times 4x is going to be 32a. And we have 8 times negative 4 is going to be negative 32. And then we have just less than negative 192. Okay. Again, we're going to solve it like how we normally do. We're going to add 32 to both sides. And then I'm going to be like 32a is less than negative 192 plus 32 is going to be negative 160, negative 160. Then from here, we're going to divide by 32, and what do we get? Oh, we got a whole bunch of 32s going on here. A is less than negative 1, 2, 3, 4, 5, 5. Okay, and remember, there is a time that you do need to know. When we divide and multiply by a negative number, we do have to flip the inequality. Okay, so that's only when we multiply or divide by a negative number. Not if we have a negative number. So here we go. We're going to go at negative 5. It says a is less than negative 5, so a has to be less than. Oh, that's a bad arrow. There we go. Less than negative 5. All right. 23. Again, I have parentheses here. You could still divide it first if you wanted to. So, for example, if I have 7 multiplied by, so if I just divide both sides by 7, still works here. Okay. It does not break any mathematical rules. So we got n plus 6 is less than or equal to 84 divided by 7, which is going to be 12. All right, but that does shorten some of our, or make some of our numbers smaller. And then I'm going to subtract 6 on both sides, and what do we end up with? We get n is less than or equal to, why do I have all these less than or equal to's? Did I not do any greater thans? I'm so sorry. I did not pick these very well. I do apologize for that. 12 minus 6 is going to be just 6. We're going to go over to 6, and we'd be like, oh, it's not an open circle, it's a closed circle, because it can equal it. Remember, equal it. So n is less than 6. Man, and I don't have any dividing in here. Should have picked better problems. I apologize. Again. So again, right here on 24, 4 times 8v is going to be 32v. 4 times negative 1 is going to be minus 4, less than or equal to 92. And again, it's a two-step. So we're going to add 4 to both sides. and we have 32v, and 32 comes out so many times. I don't even know why. Is less than or equal to 96, and we're going to divide by 32 on both sides. And we have v is less than or equal to 3. So we're going to go over to 3. This is less than or equal to, so we're going to be like, shade it in. And we're going to go v is less than, so anything to the left is good. I'm just going to box our answers. Done. Now we're going to go into compound inequalities. Please make sure if you're doing, like, if it was like v is greater than, right, 7, let's just say, so it would go the other way. I don't know why I don't have that example in here. Not a good one. I apologize. Okay. So number 25. We're a quarter of the way there. I'm so sad. Okay. So compound inequalities, we are going to be, I'm going to have to actually write this down again because it'll be easier to show the work that way. So again, you can kind of cover up this left-hand side and how it is literally a two-step equation. So I'm going to just put like these little dots right here, a dotted line, just so that you can see where everything's at. And so again, if you look at just the inside, that's where the A is. And I have a -4, so I'm going to have to add 4. So instead of adding 4 to both sides, we have to add it to all 3 sides. So do you see the third side like that? So we have the left, the right, and the middle. Okay? Because we're kind of doing things simultaneously. So -12 plus 4 is going to be -8, less than or equal to. And so it's -8a. That's going to be less than or equal to 8. Right? And then we have, a -8a. So we're going to divide by -8 on all 3 sides. Okay, now this is what I was talking about. When we're dividing by negative, we've got to flip the inequality. So -8 divided by -8 is going to be 1. Instead of less than, we got greater than or equal to. We got a. And again, we're dividing by negative, so greater than or equal to -1. Makes sense. So a is going to be greater than a, which is greater than -1. So a is in between -1 and 1. So we're going to be like 1 or -1, 1. And we know that it's going to be closed circle for both of them because we have a line under both of them. Is equal to. And a is going to be in between, so we're going to be like, boop. It's like that. Kind of looks like a musical note. Oh, here we go. That's our answer right here. And the graph is our answer. We have 2 answers. Okay. One is the algebraic version, one is the visual. Okay, so we got number 26. 7 is less than -10n plus 7. If you have not paused yet, please make sure you do that and do this by yourself. Try it out. It will help you tremendously, your brain tremendously if you do this by yourself. Okay, so again, you're looking at the middle. You're not looking at the edges. You're looking at the middle to see what you need to do. You're going to get rid of this -7. And okay, this is going to trip people up, but did you notice 7 minus 7 is 0? A lot of people just like ignore that then. They just erase it. This doesn't even exist, right? But you need to write that down. 7 minus 7 is 0. Is less than -10n, because 0 is still a number, right? It's still a solution. Less than or equal to 60. And then we're going to divide by -10. Divide by -10, divide by -10, all 3 sides. And we get 0 divided by -10 is still 0. Remember, we divided by negative. You see, we got to flip that inequality and flip the inequality, and that's going to be -6. All right. So we know that 0 is bigger than n, but n is bigger than -6. So we know it's in between 0 and -6. That's where all the solutions lie. We're going to 0, -6, and 0. So at 0, it's open circle. At -6, it's closed circle. And we know it's somewhere in between there. All right. Just do a box this time. All right, 27. Here we go. I'm going to, again, copy this down. Make sure you do that as well. All right, looking at just the middle, we're going to add 5 to both sides, or all 3 sides, I should say. And that's the part that most people mess up on. So a negative 15 plus 5 is going to be negative 10, is less than 10x, which is less than 80. All right, now I'm going to divide by 10 because by the x is the 10. Did not divide by negative numbers, so I'm just going to write it as is. So negative 1 is less than x, which is less than 8. All right, so we know that x is somewhere in between negative 1 and 8. Here's negative 1. Here's 8. Both of them are open circle because there's no equal to sign. We're going to be like that. Done. 28. Again, we're going to copy it down just because hard to show the work there. Negative 3. Half the battle is copying it down correctly. And again, we're going to subtract 7 on all three sides. Anywhere there is an inequality or an equal sign, those are sides. Each of those are sides next to them. So we're going to have negative 15. It's not the color I want. Yeah, negative 15 is less than or equal to negative 5x, which is less than or equal to negative 10. We're going to divide by negative 5. Ooh, we're dividing by negative. What does that mean? All right, we get 3 is greater than or equal to, again, we flipped it because we multiply or divided by negative. And negative 10 divided by negative 5 is going to be positive 2. So we're saying that 3 is bigger than x, which is bigger than 2. See how it still makes sense? If we didn't flip it, it'd be 3 is less than x, which is less than 2. And that does not make any sense. Because how could something be bigger than 3 but less than 2? So again, we're going to go to 2 and 3. And both of them are closed circle because they both have an equal sign underneath it. We'd be like, boom, headphones. All right, number 29. These are also compound inequalities, but in this case, this is an or. So we're saying there's two criteria. It's one or the other. Either one will be fine as long as it fits either one of these criteria. So if you're taking a look at this one, number 29, we have 6 plus x is greater than 15, or x minus 6 is less than or equal to negative 1. Just one-step equations here. We're just going to subtract 6 on this one. We don't have both sides because there's only one inequality for each of them, right? So we just have x is greater than 9. Or, do this one really quick, we're going to add 6 to both sides, and what do we get? X is less than or equal to 5. So the criteria is twofold. It either has to be greater than 9 or has to be less than or equal to 5. Can't be both. That's why there's an or there. So here's 9. Here is 5. There we go. And it says 5 is going to be equal to. So it says x is less than. So we're going to be like less than. Or x is greater than 9. So greater than 9. Like this. All right. No, number 30. Negative 8n plus 8 is less than negative 16, or negative 6n minus 4 is greater than or equal to negative 16. All right, let's solve the left one first. We're going to be subtracting 8 on both sides. And we got negative 8n is less than negative 24. And then we have divide by negative 8, divide by negative 8. I am dividing my negative number, I notice. So I'm going to remember to flip the inequality. So n is greater than 3. Or, let's try the other one. It should be taking me about the same amount. And add 4 on both sides. And I have negative 6n is greater than or equal to negative 12. I'm going to divide by a negative 6. And I get n. Again, I divided by a negative number, so I'm going to flip the inequality. And that's going to be 2. So I have n is greater than 3. So greater than 3 is this way. or n is less than or equal to 2. So again, so n can be any number except for 3 and anything between 2 and 3. So it can't be 2.5, can't be 2.7. All right. We got our last two ors. I'm going to copy it down here. All right. We're going to add 10 to both sides. Did you do this by yourself? I hope you're just not listening to me. Come on now. -5 plus 10 is going to be +5. And then I have divide by -5. Ooh, I'm dividing my negatives all day long now. A is, again, less than -1. Or I'm going to add 3 to both sides. And I have 8a is greater than 24. And then I'm going to be like, divide by 8, divide by 8. And again, I'm not flipping the inequality because I did not divide by negative number. So I have a is greater than 3. So here we have 2. So a is less than -1. So we have -1, open circle, going to the left. Or a has to be greater than 3. So we're going to be greater than 3. So it'd be 3.1, just can't be 3, right? Because 3 is not greater than 3. That doesn't make any sense. You're not better than yourself, right? All right, last one for 32, we got 3b minus 7 is greater than or equal to -13. Or 9 plus 3b is less than or equal to -3. Again, we're going to solve them. I'm not using colors this time. I'm just going to solve them. I added 7 on both sides because by now you should know how to solve these. Like it's, unless you weren't watching from the beginning, you were just stuck on this one, in which case I apologize. But -13 plus 6, 7 is going to be -6. And then we're going to divide by 3 on both sides. So b is greater than or equal to -2. Or we're going to subtract 9 on both sides. See what we got. 3b is less than or equal to -12. Divide that by 3. And b is, again, we did not, what is it called? We did not divide by a negative number. So let me put the answer back. Or b is less than or equal to -4. There we go. So b is greater than or equal to -2. So we know it's going to be closed circle. Greater than means go to the right. And b is less than or equal to -4. So close circle at -4 and go to the left. All right. Congratulations. You just finished day 1. Now on to day 2. You need to take a break, but don't forget to come back. Oop, wrong way. Be like day 2. Welcome to day 2 of 4. All right. This one is all about graphing. It's just literally all graphing. Okay. Again, for 33, these are all, for the next 4 problems, they're all slope-intercept form. So we're going to look over 3 different kinds of forms. This is the first one and the most common one, if I can get there. Ooh, too much. This is the problem here. All right, so again, first we're going to look at the slope and the y-intercept. I'll look at the y-intercept first. So this first one right here, let me call that orange. So this is our y-intercept. The number that's by itself, that is our y-intercept. Like y-intercept. Okay, and I'm going to go on the y, and there you go. Oh, look, -3, yay. Done. Okay, and then the other color, which I'm going to make green, notice that there is no number in front, right? There's no number front. Remember, there's like a 1 in front. So the slope is like just going to be 1/1. Okay, so I'm going to go up 1 as positive, so I'm going to go to the right. So because it has a positive, so up 1 and to the right. So going a positive slope this way, 1/1. Or we can go down into the left one, right? That's going to be the other way to go. Okay, but remember, it has to be traveling up, right? That from left to right, it's going up, and that's going to be our line. There we go. And we're just going to now draw the line. Boom, done. Okay, and so we're going to look at number 34. Oh yeah, number 33 done. That's all we got. I'm going to use the same colors. I'm going to use orange for my y-intercept. So my y-intercept is here, -2. That's going to be right here, -2. My slope is just a negative number, so it's just negative. So remember, it's -1/1. So I know it's a negative slope. It's gonna go decreasing. So I'm gonna go up 1 and then to the left 1. Right, up 1 to the left 1. So if I do that, then if I go from left to right, I know I'm gonna go down. Okay, or down 1 and 1 to the right. I'm gonna continue that pattern all the way down because what is the slope? It's just repeated, same action every single time. Okay, I'm gonna make my line. Ooh, it was going so well. Look at that. That is a good line. Good looking line right there. Okay, well, kind of. All right, done. Do you see? That's it. Y-intercept, slope. Make points. Okay, okay, y-intercept. Right here I have -1. Okay, I'm including this guy right here, so -1. Done. Make sure you do it on the y-axis. It is never the x-axis, right? It's not called the x-intercept. It's just the y-intercept. And then my slope is this 2 right here. But remember, we like fractions here because it helps us with both. So it's just 2/1. If there's no number on the bottom, it's a 1. So we're going to go up 2 from the y-intercept. We're going to go up 2 into the right 1. So it is a positive slope, so we're going to be climbing, going up, or going down and to the left. And then we got our line. Done, just like that. Slope helps us to know how tilted something is, right? That one's kind of steep. Wouldn't want to climb that up. All right, right here. Oh, look at there's nothing here. So if there's nothing there, do we get the x with a number in front of it, which would be our slope? Remember, it's like a +0, right? We're not adding any numbers to that. So it's just going to be here at 0. And then our slope is going to be -2/1. So it's this guy right here. This is our slope. So it's a negative slope. So we're going to go up 2. And instead of going to the right, because that would be positive, going to the left, because we're going to bring this down up 2/1 or down 2 to the right 1. So that's our slope. It's a decreasing slope. So we're going to just be going down just like this. Good job. All right, done. So if you look at number 37, do you see how this looks a little bit differently? This is our standard slope. I'm going to bring this down just a little bit without going too much. There we go. And so what we're going to do, there's 2 ways to do this. We can find the intercepts, but intercepts only works like some of the time because sometimes the intercepts are not like good integers. So I'm actually going to solve for this. Why did I do that? So I'm going to actually solve for y here so that we could change it to slope-intercept form like the previous problems. So I'm going to, here's y right here. So I'm going to get rid of this 5x. So I'm going to subtract 5x, right, to make this 0. And what do I have left? I'm going to move this over this way. So I have -2y is equal to, these are not like terms, -8 and -5x. So I'm going to just write them separately, -5x minus 8. Okay? If they're not like terms, you cannot just combine them. It does not work that way because they're not the same. So here we have -2, so we're going to divide everything by -2. And we got y is equal to negative divided by negative is positive. So I'm going to leave that as a fraction because remember our slope can be a fraction. It's fine. And -8 divided by -2 is going to be +4. All right. So again, we're going to do the same now that we have in slope-intercept form. We are very familiar. That is not orange. We're very familiar with this. Remember this, the orange. Our y-intercept is 4. So we're going to go up to 4. My slope is going to be 5 over 2. I can't go up 5 into the right 2, so I'm going to have to go down 5. 1, 2, 3, 4, 5. Did I say to the right? Oh, no, because I was going up 1, 2, 3, 4, 5. 5 down 5, and we're going to go 2 to the left. Because remember, it's a positive, so we want it to increase. So again, down 5 to the left. And draw my line. I like to have more than one point just so that I'm accurate. And I can see that I'm doing this correctly. We're going to do the same thing as we did before. Notice this is in standard form. So we're going to just subtract 2x from both sides. And then what do we get? We have y is equal to, right, negative 2x plus 3. All right. We don't have to divide anything because y is already by itself, so we already have our answer here. So we got this plus 3 as our y-intercept. Okay. And our slope is negative 2 over 1. It's this guy right here. So I'm going to go up 2 and then to the left 1 because we know it's a negative slope. I'm going to fill in the other points using the same pattern. And then I'm going to draw my line. Yay. Done. We're going to practice this 2 more times. Again, please try it by yourself. Don't try to do this without practicing it by yourself. Okay, again, pause it. Try to do this by yourself. Change this to slope-intercept form. I'm going to subtract 3x on both sides, and I get negative 2y. Don't forget the negative from the minus is equal to negative 3x plus 8. Next step is to just divide by negative 2. Everything is going to be divided by negative 2. So y is equal to negative divided by negative is a positive, 3 over 2x, and 8 divided by negative 2 is minus 4. So now that it's in slope-intercept form, we can graph it. So we're going to start at negative 4 as our y-intercept. And our slope is 3 over 2. It is positive. So we're going to go up 3 and to the right 2. Up 3 to the right 2. Right? I can't go down and to the left because there's no room for that. So there we go, just like this. Okay, that should be crossing the orange line, right? Orange point, I should say. There we go. All right, last one of this kind. If you notice right here, it says we're still in standard form and we're going to change it. So minus 2x on both sides. And we get 5y is equal to negative 2x minus 5. We have that 5 over here, so we're going to divide everything by 5. And what do we have? That's going to be y is equal to negative divided by positive is still negative, so negative 2/5 x, and minus 5 divided by 5, which is 1. So again, my y-intercept is going to be negative 1. Slope is going to be negative 2/5. So I'm going to go up 2, and then not to the right because that would be positive, to the left 5. Or down 2 to the right 5. So we know we have a decreasing line. Okay, and it should, please make sure you're using ruler. Can't really use one on this thing, so it's a little more difficult for me. Okay, now this is the third form that we have seen. Technically, I guess you could change this to slope-intercept form, but why do that when you could just, it gives you all the stuff. This is called point-slope form. You know why it's called a point-slope form? Because it gives you two things, a point that's on the line and the slope. Those are literally all we need. Because what is y-intercept? A point on the line. So this point is just not the y-intercept, it could be any point on the line. So I'm going to use, let's see here, purple. So purple is going to give me the point. So purple is going to be right here. So originally, let me just write it down here. Y minus y1 is equal to m times x minus x1. So notice that this right here and this right here, those correspond, right? And the m is 3, right? So notice it's supposed to be a minus, which means my y is just the 2. Okay, this was supposed to be a minus, but it's now a plus, right? So this is, instead of being a +6, it is a -6. Okay, so I'm gonna just kind of color coordinate here. So basically, I like to think of it as it's opposite of what we see. So, oh, did you see me through those colors? That is silly. So the -2 is for this 2 right here, and the +6 is for this -6 here. Okay, that's where that's from. And my slope is still going to be green, so I'm going to be like, there's my green right here, slope. Okay, so again, we're going to work with the point. Oh, pink and blue, we'll call that purple. So purple will be my point. -6, 2. So -6, +2. Here's my point. That point is on the line. Okay. And then the 3, I'm going to use the 3 to get the other points on the line. So we go up to 3 and over to the +1. Remember, because it is a +3, we go the opposite direction. Okay, we're going to draw our line. Bam. Done. Yay. All right, number 42. Again, we're going to say what our point is. Our point is x, go with the x. X is 5. Since it's a -5 here, we know it's a +5. And for the y, since it's a -1, it is a +1. Remember, our x coordinate is coming from the one that's next to the x. Our y coordinate is coming from the one that's next to the y. And again, our slope is going to be this guy right here, -12. -12, -2. Oh my dear, I am losing it. I'm just going to kind of color this out. So this is -1, so it's going to be +1. And this is -5. I thought I did the coloring backwards again. This is a 5 right there. Okay, so my point is 5, 1. So I'm going to go over to 5, up 1. There's my point on the line. And slope of -2, so I'm going to go up 2 to the left 1 to make that a decreasing slope. Or down 2 and right 1. All right, we're going to draw our line just like that. Done. Number 42. Okay, last two problems, at least for point slope form. We're going to, again, draw the point. Our point is going to be x is 3. Since this is -3, is +3. Y is going to be -2, since this is +2. So 3, -2. So 3 to the right, down 2. There's our point. And then our slope is this 3 over 5. We're going to go up 3 to the right 5. 1, 2, 3, 4, 5. Ooh, just barely made it. Or down 3 and then to the left 5. Right there. And do it again, down 3 to the left 5. All right, and we're just going to draw that line now. If ever you kind of have to like kind of try and make it fit, that means one of your points are off, right? It should naturally fit very automatically. Okay, that's an easy way to check. If you like counted, like you could have went down 2 instead of 3, or you could have went 6 instead of 5, right? So those are simple errors to make. So this kind of doing multiple points helps you to notice those things. It should all fit straight into a line with no problem. All right, our point again is going to be, our x is with the x, so +4 is going to be -4 for the x. For the y, it's going to be +6, so it's -6 for the y. So it's going to be -4, -6, right there. And our slope is going to be -1/3. So I'm going to go from this point I'm going to go up 1 and then to the left 3 because we know that it is a decreasing slope. So down 1, and then our point. Our line is just going to be like that. Okay, we're already done with that. We have a few more things to go for this day. Look at the inequalities, okay? It's literally the same thing as graphing a line with slope-intercept form, but now there's just a few differences at the very end. There are multiple answers for these ones, okay? So here we go. We're going to start with the y-intercept, which is, again, still orange. So y-intercept is still -4. So we're going to go to -4. Boom, just like that. And our slope is green. Remember, if there's no number in front, what is the number? It is a 1, so it's going to be like 1 over 1. So I'm going to go up 1 to the right 1 because we know that this is a positive slope. Right, I'm going to continue that on. And then we have, okay, so here's where it gets a little different. So again, if there's no equal sign underneath, right, we know it's going to be a dashed line. So this guy right here means it's going to be a dashed line. If you have something like 47, like 47, we know that's going to be a solid line like this. Okay, a little arrow like that. So that means a solid line. So this is going to be a dashed line. So we're going to have a dashed line because technically, so we're saying that y cannot equal the line. Okay, so it is a dashed line. It's like a electric fence. Don't go on it. You can't. You're gonna die. All right. So now it says y is greater than. So if you think about x minus 4 being the line, because that's how we got this line, right? So y is greater than that. So all of our y values are up here. See, -3, -2, -1. All of these numbers are getting bigger than this line, right? So we know we're going to be shading on, let me get a yellow or pink. We're going to be shading on this side. We can also pick a point and plug it in. For this one, it's just faster doing it this way. I think about it conceptually. Okay, so we're going to do the same thing for number 2, or number 46. Oh, look, there's no y-intercept here, which means if there's no y-intercept, what's the number? Plus 0, so we're going to be right here at 0. All right, and we're going to use the slope. Remember, it's -5 over 1. So I'm going to go up 5, and then to the left 1 so that my line is decreasing, or down 5 and to the right 1. And it is going to be a dashed line because it is just an inequality. Ooh, let's see if I can do this. Okay, kind of, sort of. Make sure that it's going all the way across. Okay, we're not just doing like, that's too small. Okay, it doesn't work like that. Okay, so we need to determine, it says y is less than this line. So to see how it cuts the y-axis into 2 parts, the above part is 1, 2, 3, 4, 5. Those are all bigger numbers. And then -1, -2, -3, -4, those are all smaller numbers, right? And it says y is less than it. So we know we're going to be shading on the side where it's less than. Okay, so all those y values down here, less than. Okay, done. So we're saying in the shaded area, all of the shaded area is a possible solution, right? Any of these numbers work, okay? Or any of these, I should say, coordinates, ordered pairs work. So if I were to plug in -3, 2, which is in this shaded area, in there, it will work. All right? Okay, let's try this one right here. We're going to go to our orange, which is our y-intercept. We have it at -2. Great. And our slope is going to be 1/2. We're going to go up 1 to the right, too, because it's a positive slope, so we're increasing. Remember, we're always going from left to right. It is going to be a solid line. It should be like solid. So I'm going to make sure, because it can't equal it, I'm just going to make it into a solid line like that. All right. So again, y is less than this line that we just made. So where are all the y numbers less than? It's going to be down here. All these numbers right here, less than. Because all the numbers above are getting bigger, right? So I'm going to just shade down here. Just like that. And I'm sure you can do a much better job of shading than I can. All right, we're going to take a look at number 48. So 48, we're still looking at the y-intercept. There's -1 right here. So there's our -1 right on the y-axis. And then our slope is -4/5. So we're going to go up 4 and then to the left 5 because we know that that will make us decreasing our slope. Down 4 and then to the right 5. And again, it is going to be a solid line because we have that little equal sign there, right? So I'm going to just be like, done. Like that will, just line part is done. And then we're going to be shading on which side. It says y is greater than. So if it's greater than, that means it's going to be on all of these y numbers that are bigger than the line, right? So here we go. We're going to just shade all this. Stay within the lines. Okay. So that is it for inequalities. Now, I told you we're going to be graphing for days here, right? So graphing, we're going to be doing systems here. I decided to bring it here because it's just reiterating all the things that we've been doing today. Okay, or else it'll make day 3 like really, really long. Okay, so I just brought it here. Again, we know how to do this. We did this before, except we're going to do 2 lines in one graph, in one coordinate plane. All right, so the first one, so we have this +3 right here. So again, 3. And then we have our y-intercept, or our slope of -2/1. We'll just be like over 1. So up 2 to the left 1. Down 2 to the right 1, because we know we want a negative slope. I'm going to just continue the pattern. Okay, there's no solid or dotted here just because these are equal signs. So it's always going to be solid. Okay, something like that. And then we're going to look at the second one. I'm going to make that a pink line. So again, I'm going to start at -3 right here. So here's -3. My slope is just going to be 1/1 since there's no number in front. So up 1/1 to the right 1. We know it's a positive slope. Oh, look, do you see what it has in common? I'm just going to continue that just so that I can draw this line a little bit better. And okay, again, when we have this, we want it to solve each system. Basically, in order to solve it, we need to know where they intersect. Where do they meet, right? They meet at this point right here, right? And that's going to be at 2, -1. Don't just graph it and be like, I'm done. You're not done. You need to actually tell me what the point is. What is the solution? You're not tell me, but whoever, just tell me what the solution is. Okay, that's it. We're going to do 50. We're, I think, almost halfway there. Good job, guys. We're going to start with the blue one. Okay, again, we're starting with a +1 as our y-intercept. And then -3/1. So we're going to go up 3 and then to the left 1 to make sure that it is decreasing. Again, if you don't remember how to graph these guys, then you need to go take a look at some of those previous problems where we just do one of them. I'm not going to be doing too much color coordination here except for which line is which. So here, the -4 right here, it's going to be our y-intercept. And then we have a slope of 2/1. So it's going to be +2/1. Do you see where they intersect? Do you see what I see? All right, we're going to just draw that line. So it should make some sort of X, right? And what does that mean? That just means that the solution is 1, -2. So I'm going to be like, ooh, 1, -2. There we go. Done. Once you have the solution, we are good to go. 51. Ooh, 51, we have, so with the blue, and again, this is +3, so we're going to go up to 3 right here. And we have a slope of -1/2. So we're going to go up 1 and then to the left 2. Right? That means that we are going to be decreasing because it's a negative slope. And then we're going to go with our 5. I'm getting tired too. So we're going to start at +1 for our second line. So here's +1. Our slope is -3/2, so it's a negative number again. We're going to go up 3, and this time I only went up 2. Up 3, and then to the left 2. Ooh, look. Down 3 to the right 2. We're going to draw that line. Sorry, it should be like right there, right where the cross is. So that solution is going to be -2, 4. Yay! All right. We're gonna do, here we go. I just need a little bit more room here. There we go. And we're gonna start with the blue line again, and we're starting at +3 for the y-intercept. Again, it's always the y-intercept, peoples. 1/2. So we're gonna go up 1 and then to the right 2, right? Because we know that is increasing. Ooh, totally missed that one. Let's see if I could do a better job. It's not bad. And then second one, we have a -3. So we're going to start at -3. And then we're going to go up 7. So 3, 4, 5, 6, 7, and over 2. Ooh. I can only have 2 points at this juncture. Where do they cross? You'll see it right here. So it's going to be 2, 4. Yay. All right. So now we have the same thing, system of equations, but we have them in in standard form. So you know how we do standard form. We're going to have to do that. So there's a little bit of work we need to do here. So I'm just going to copy this down over here on the right. So I'm going to just be like, here, look at my work. X minus 2y is equal to -8. And then I'm going to subtract x on both sides. And I have -2y is equal to -x minus 8. And then I'm going to divide by -2 on both sides. I get y is equal to negative divided by negative is positive. Remember, there's no number here. So remember, there's that in that invisible 1. So it's 1/2 x, because that's not 2, because 2 does not go into 1 evenly. Yeah. And then negative divided by negative is positive. So it's +4. All right. Again, I am going to just graph that. So we're going to go up to 4 for the y-intercept. It's going to be up 1 and to the right 2. It is a positive slope. So there's my line. Okay, I'm going to use, let's use purple this time. So purple is going to be my second equation right here. And that's going to be 2x plus y is equal to -1. And I'm just going to subtract 2x on both sides. And what do I have? I have y is equal to -2x minus 1. Remember, we cannot combine like terms there because the 1 does not have an x, right? Okay, so again, we're going to start at -1. And my slope is -2. So I'm going to go up 2 and to the left 1. Oh, look at that. You can see what the solution is already. But I'm still going to draw the line. Right, solution's right here. And I'm going to just write it here. So that's going to be -2, 3. Yay. So there are 3 more problems like this. So try it yourself. If you have not already, please do that. All right, we'll start with the blue one first. So x minus 3y is equal to -6. I'm going to subtract x on both sides. This is what it looks like in one color. -3y is equal to -x minus 6. And then I'm going to divide by -3 everything. Todos. So y is equal to, again, if there's no number there, is a 1 there. So negative divided by negative is positive. 1/3 x. -6 divided by -2 is -3, is +2. Or I had the answer in my head. So there's 2 right here, and we're going to go up 1 and then to the right 3. Can't do that anymore, so I'm going to go the opposite direction. There we go. And then we're going to go for the purple. Should we go for the maroon? Okay, so here's 5x plus 3y is equal to negative 12. I apologize for these answers on the side. We're going to subtract 5x on both sides. That's next. And we get 3y is equal to negative 5x minus 12. And we're just going to divide everything by 3. And we get y is equal to negative 5/3. Remember, we like fractions for slope, minus 4. All right, and then so we're just going to graph that at negative 4. And our slope is negative 5/3, so we're going to go up 5, to the left 3. That's all I can do, actually, because I can't go. Okay. I really miss my ruler. But you know where it crosses right there? It's going to be negative 3, positive 1. Bam. All right, we're going to do this 2 more times. All right, you guys got this. I got this. We're going to figure it out. Okay. Scroll up a little bit. There we go. Perfect. All right, so we're going to do the same thing for x, or for the first equation, we got x plus 4y is equal to 16. Subtract x on both sides. And we got 4y is equal to negative x plus 16. Right, then we're going to divide everything by 4. So y is equal to negative 1/4 x plus 4. All right, so we're going to now graph this. We're going to go to y-intercept of 4. And this is going to be negative 1/4, so up 1, and then to the left 4, so that we keep our negative slope here. And we're going to draw the line. Okay, that is so crooked, but that's fine. And then we're going to go with this color, magenta-ish kind of color, 5x minus 4y is equal to 8. I'm going to subtract 5x on both sides. We got minus 4y is equal to negative 5x plus 8. That's a plus. We'll figure that out. And then we're going to divide by negative 4, everything by negative 4. Y is equal to negative divided by negative is positive, so I just have 5/4 x. 8 divided by negative 4 is minus 2. I'm going to go here to minus 2. And I'm going to go up 5. Here's 2, 5, and then over 4. Oh, look, do you see where it lands? I can't go the other way, so this is literally all I have. Okay, no other point to check it with. That's what we got. And our solution, yep, right here. So that's going to be at 4, 3. Remember, x always comes first. All right. Last one of these kinds of problems. We have, let's do this guy right here. And so we got 3x plus 4y is equal to negative 4. Again, subtract 3x on both sides. If you do this, you'll see the patterns and you'll be like, okay, we've done this. Like if you've done one, we've done a million of them, right? So that's why it's important to keep practicing, even though you're like, oh, I think I remember what it is, right? So keep practicing so your brain won't forget it. So divide by 4. So y is equal to negative 3/4x minus 1. Okay, we're going to start at negative 1 right here. And then it's positive 3 to the left 4. It's decreasing just like this. We're just going to go down, go down. Yay! All right, our second line. So we have this, and we'll just write it on the bottom here. We got x minus 2y is equal to negative 8. And we're going to, or not add x, we're going to subtract x on both sides. And we have negative 2y is equal to negative x minus 8. Okay, let's see if we can scroll this down a little bit. That's a little lot of it. Just a tad. Just a smidgen. All right, we're going to just divide everything by -2. -2. And we get y is equal to, a negative divided by negative is positive, so we just have 1/2 x plus 4. We're going to go over here to 4 on the y-axis, and then our slope is 1/2. Okay, there's a positive slope. Look at that, where they intersect, just like that. So that our solution is going to be -4, +2. Yay! Well, look, we're in day 3 now. All right, this is going to be the same thing we were doing above, except without a graph. We're going to do it algebraically. Okay. All right, so when you have two equations in slope-intercept form, yeah, we could graph it, but do you really want to go to -24 and then go? Yeah, it's a lot, right? So sometimes solving it algebraically is easier or faster. So what we're going to do is we're going to use substitution. So the way we use substitution is we're going to substitute it in, right? Since both, like the 5x minus 24 is equal to y, like they're both, this is equal to y, but so is 3x minus 16. Since they're both equal to y, we're just going to substitute it in. So since they're both equal to y, what do we know? That 5x minus 24 is equal to 3x minus 16. So I'm going to be like 5x minus 24 is equal to 3x minus 16. Since they're both equal, so this guy is here, and this guy is here. They're literally equal to each other. Why? Because they're both equal to the same thing. Okay? So let's just solve it. So now we have the equation. We're just going to solve for it. We've been doing this, right? This was like day 1 stuff, right? Again, we have x's on both sides of the equation, so we're going to actually get x's on one side first. I find that this is the least confusing way of doing it. So 5x minus 3x is going to be 2x minus 24. That's an x. Is equal to -16. And then we're just going to add 24 to both sides. And we have 2x is equal to -16 plus 24 is going to be 8. And then last step right here, divide by 2. And we get x is equal to 4. And you're like, yay, we're done. We're not done. Because remember, we want to have an ordered pair, just like how we did like for when we're graphing the 2 lines, right? When we graph the 2 lines, we had a solution, right? We want to know what point works for both equations. So once we have x, we can use either the top or bottom equation to figure out the rest of it. So we're going to use which one? Shall we use the top one or the bottom one? The bottom one, smaller numbers, so let's work with the bottom one. That's orange. I'm going to just make it orange here. So we got y is equal to 3. But instead of x, we know what x is, right? X is 4. So we're going to plug that in. I'm going to just draw a line right here for this. Like, that's where we got it from. Or should it be like the other way? So I'll be like arrow going here to show that that's where we got it from. I don't know. Anyways, I'll just go like this. We're going to continue on. And so 3x and then -16. Right? So again, exactly like that orange equation, except instead of the x, we put in a 4. So then we got y is equal to 3 times 4, which is 12, minus 16. So y is equal to -4. All right, so now that we have that, we know our x and y, so we're going to be like, our solution is 4, -4. Yay. And let me just color coordinate that. I'm going to be like green, green, and yellow. I have not used yellow, so I'll be like yellow, yellow. That's where those came from. All right, we're going to do the exact same thing for 58. So -3x minus 1 is equal to -7x minus 9. All right, and again, we're going to just put the x's together by adding 7x to both sides. If you wanted to add 3x to both sides, you totally can do that. That is up to you. And negative 3x plus 7x is going to be 4x minus 1 is equal to negative 9. And again, it goes down to a two-step equation. I told you, almost always goes down to, it simplifies down to a two-step equation. So 4x is equal to negative 8. And then we're going to divide by 4. What do we get? X is equal to negative 2. Remember, we're not done yet because we still got to figure out the y. So you can choose the top or the bottom one. What would you like to do? You want to do the top one? Smaller numbers? Thank you. So y is equal to negative 3. Instead of x, we're going to plug in. We know what x is, negative 2. And it's going to be minus 1. So we got y is equal to negative 3 times negative 2 is positive 6 minus 1. So y is equal to 5. So here's our point, negative 2, 5. Yay! Good to go. All right, we're going to do a couple more of these. Notice right here, oh, not that way. We're going to go down. We're going to do the exact same thing for 59 and 60. So go for it. So again, we're going to set them equal to each other. Negative 7x plus 17 is equal to 3x minus 3. And we're going to, I'm going to add 7x on this time. And we got 17 is equal to 3 plus 7 is 10x minus 3. I'm going to add, again, two-step equation. We have 2 steps to get the answer. So 17 plus 3 is 20 is equal to 10x. And then we're just going to divide by 10. Because that's what's in front of the x. And we got 2 is equal to x. Okay. So I'm going to use this bottom equation because that looks a little bit more friendly, right? So y is equal to 3 times something minus 3. Okay, so 3 times x, which is 2. There we go. And we're going to be like y is equal to 3 times 2, which is 6 minus 3. So y is equal to 3. So 2 comma 3. Yay! That's a parentheses there. Let me try that one more time. There we go. Okay, again, do that with 60. 7x minus 7 is equal to negative 6x plus 6. And then I'm going to be like, oh, add 6x to both sides. What do we got? We got 13x minus 7 is equal to 6. Again, two-step equation. Add 7 to both sides. And we have 13x is equal to 13. And then divide by 13 for both sides. And we have x is equal to 1. Okay, I'm going to use the bottom one. I mean, it's slightly, y is equal to negative 6 times 1 plus 6. Y is equal to negative 6 times 1 is negative 6 plus 6, which we know is going to just be 0. Don't be like, no solution. No, 0 is a solution. So your solution is going to be just at 1, 0. Okay, what happens when we get to something like 61, right? 61 looks different than the previous 4 problems, right? Only one of them is in slope-intercept form. The other one is in standard form. When we have something like this, again, we have to do something with substitution. So what I'm recommending is that you see how this is equal to y. So we're going to plug it in for this y right here because they're both equal to y. See what I'm saying? So we're going to plug in the orange in for this orange y. Okay, so here we go. So negative 5x minus 8 times, what is y again? Equals negative 1. So again, the y I'm going to make orange. So instead of y, we're putting in 4x plus 14, right? So again, it's literally the bottom equation, except we're replacing the y with the 4x plus 14. And why do we do that? So we could actually solve it. We can't solve an equation with two different variables because there's a lot of different combinations you could use to make that work, and not just one. Okay, so here we go. We've done this before in our solving equations part, day one. So again, we're going to just distribute negative 8 times 4x is going to be minus 32x. Ooh, the 32x is back. And then negative 8 times 14 is going to be minus 112 is equal to negative 11. I hope that's right. Yeah, that's right. Okay, and then from here we have some like terms. So this negative 5x minus 32, which is going to be negative 37x minus 112 is equal to negative 1. I feel like there's a mosquito. Just like that. And then here I'm going to just add 112 on both sides. And I have negative 37x is equal to 111. All right, and then I'm going to just divide by negative 37. And what do I have? Negative 37, x is equal to 1, 2, 3, 3, negative 3. Okay, so I know my x, we need to figure out the y. So plug it into which one? Either one is fine, but honestly, the top looks a lot easier, right? Because it's already solved for y, so it's less for me to do. So y is equal to 4 times the x, which is negative 3, plus 14. So I'm going to plug in negative 3 for x. All right. Then I'm going to just simplify that. Y is equal to, that's going to be negative 12 plus 14. So y is equal to 2. So our answer is negative 3, 2. That's where those two lines over the graphic, that's where they would meet. All right. So we're going to do the exact same thing as we did for number 62. So we're going to notice that the slope-intercept form is on the bottom. So we're going to plug it into the top. So we got 6x plus 4. Instead of y, what are we putting in? We're putting in x minus 6. Right? That right in there. And we're going to finish it up, and it's equal to 16. All right, again, we've seen these kind of equations before. Please refer to previous day one problems. 4 times x is plus 4x. 4 times minus 6 is going to be minus 24 is equal to 16. 6x plus 4x is 10x. Minus 24 is equal to 16. Now, again, two-step equation. Add 24 to both sides. That's a plus. And we get 10x is equal to 40. Divide by 10. And we get x is equal to 4. All right. We know that x is equal to 4. We need to figure out what y is. So I'm going to just use this equation right here. Why? Because the bottom, we could use the top one, but it's just more work. Why do more work? And instead of x, we're going to put in 4. I don't need parentheses really because I don't have anything outside of x that I need to be multiplying with. So I'm going to continue the equation. So 4 minus 6, just like x minus 6, 4 minus 6, which is negative 2. So my answer is going to be 4, negative 2. Yay! Happy days. All right, 2 more problems like this, and then we're going to go into elimination. So let's take a look. We're just subbing it in, and we got 12x minus 2 instead of y. We're going to put in something. What are we putting in? We're going to put in this guy right here in for y. So it's going to be 6x minus 23. And again, we're going to just be like 12x minus 2 times 6 is going to be 12x. 2 times negative 23 is going to be plus 46 is equal to 46. 12x minus 12x. Ooh, that's 0. That cancels out. And all I have left is 46 is equal to 46. What happens? Remember what happens when that happens? 46 is equal to 46. That is true, which means that we have infinite solutions. I like to say infinitely many solutions, but the answers here say infinite solutions, so we're going to leave it at that. Because how many solutions are there? An infinite number. So basically, if you were to graph it, it would be like on this the same line, basically. They both represent the same line. All right, last problem of this kind. And we're going to be like -8. I notice that the top is already solved for y. So I'm going to just copy the bottom and plug in the top. So -x plus 7, I'm going to put a parentheses for what y should be, is equal to -5. And that -5, no, the y is going to be all this guy right here, -3x plus 15. All right, let's solve it. So we got -x plus, just kidding, not plus. 7 times -3 is going to be -21x. 7 times 15 is going to be plus 105 is equal to -5. So again, like terms are on the same side, so it's just going to be -22x plus 105 is equal to -5. Again, we're going to subtract 105 from both sides because we're back to, again, two-step equation. So this is going to be -110. We're going to just divide that by -22. We got x is equal to 2, 4, 6, 8, 10. We're going to go +5. I almost boxed it, but I forgot. What do we need to do? Find out what the y is. So I'm going to use this. So y is equal to -3. Here's x plus 15. So I know that the x is 5. So I'm going to put it in the place of x. So y is equal to -15 plus 15, which means that y is equal to 0. So again, our answer is just going to be 5, 0. Okay, remember 0 is a solution. Totally works. All right, so we're going to be solving with elimination now. Okay, what does that even mean? It means we're going to eliminate things. Okay, thus far, we've been substituting it in, right? We knew what y was, so we substituted that in to the other equation. Here, we're going to eliminate them. And if you notice right here, we want to eliminate either the x's or the y's because we're actually going to be adding these two equations together. So if I wanted to eliminate the x's, I would have to have them be the same number, right? So I'd have to multiply the top by 9 to add them up and those cancel out. Or if I wanted to get rid of the y's, I could make this 7 into a 14 by multiplying by 2. And personally, I'd rather multiply by 2 than multiply by 9. So I'm going to multiply this top equation by 2. All right. And let's figure this out. So 2 times -x is -2x. 2 times 7y is going to be plus 14y. And is equal to 2 times -28, which is going to be -56. Okay, I'm going to just copy the bottom one down. So we got 9x minus 14y is equal to 7. And if you notice, now when I add them up, y's cancel out. 14y minus 14y is 0. And we got -2x plus 9x, it's going to be 7x is equal to -49. Right? And from here, we're just going to divide by 7. It's just a one-step equation. X is equal to -7. Again, we're not done because remember, we got to plug it back in. This one, we got to do a little more work. Looks like the top would be a little bit easier, fewer, less numbers. So I'm just going to plug that in. So I'm going to be like negative whatever x is plus 7y is equal to -28. And we know x is equal to -7, just like that. So I'm going to rewrite this. So the negative of -7 is +7 plus 7y is equal to -28. And then again, two-step equation. That 7y is equal to negative 35. We're going to divide by 7. We got y is equal to negative 5. So our answer is going to be negative 7, comma, negative 5. Yay! We did it. Okay. So again, there are 3 more problems like this. Let's try it out. Looks like I would multiply the, let's get rid of the x's, because I could multiply by 2 for that one, right? So instead of just 2, I'm going to multiply by negative 2 so that I can get this 3x to be a negative 6x. Okay. I'm going to copy my top equation down because we're not actually doing anything with it. And then the bottom equation is going to look like negative 2 times 3x, which is negative 6x. Negative 2 times 5y is going to be minus 10y. And negative 2 times 18 is going to be negative 36. All right. And what do you notice? Oh, 0, 0. Actually, I have nothing left. So 29 minus 36 is not going to be 0. It's going to be negative 7. Right? We know that 0 does not equal negative 7, right? So we are at no solutions. So what does that mean to be no solution if we were to graph it? We have a line, another line, and they never meet. They are parallel. Okay? That is the only time when you're going to have no solution. They're literally no point. They share no points. So if you were to graph it, it'll literally be parallel. Okay. So we got 67. If you notice right here, oh, I don't have anything. I can't multiply the 3 to get a 4. I mean, not easily anyways, or the 6 and the 7. So what I'm going to do, I'm going to have to multiply both equations. So let's try it out. I'm going to try and get rid of the x's because those numbers are smaller. And what could I get both of those numbers to be? 12, right? Because 3 times 4 is 12 and 4 times 3 is 12. Works out like that. So I multiply the top one by 3. The bottom one I'm going to multiply by I'm going to multiply the top by 4, right? Because that's how I'm going to get 12, not by multiplying by 3. That's silly. And I'm going to multiply the bottom by negative 3, right? Because I want one of them to be negative. I'm just choosing the bottom one to be negative. All right, so here we go. I'm going to multiply the top part. 4 times 3x is 12x. 4 times negative 6y is going to be minus 24y is equal to, don't just say 12. It's 4 times 12, which is going to be 48. The bottom one, negative 3 times 4x is going to be negative 12x. This is good, so I could cancel it out. Negative 3 times negative 7 is going to be positive 21y is equal to negative 33. X's cancel out as I wanted. And negative 24y plus 21y is going to be negative 3y is equal to 15. It's going to divide by negative 3 here. We get y is equal to negative 5. We've never had to solve for x before. Here we go. Again, you can choose either equation. I'm going to choose let's go with the bottom one. Okay, I'm going to go with the bottom one. We're going to do 4 times, oops, I got so used to solving for x. 4 times x, because we don't know what x is. 7, we know what the y is equal to 11. And the y is equal to negative 5. So we got 4x minus or plus 35 is equal to 11. Again, we're going to subtract 35 on both sides. We got 4x is equal to negative 24. Divide by 4. And we got x is equal to negative 6. So our answer is going to be negative 6, negative 5. That's the solution. We got one more. All right, so let's take a look here. So I know for the 6 and the 4, like we can get 12, both of them can become 12, right? So I'm going to multiply the top one by 2, right? So that will be a 12, negative 12y. I'm going to multiply the bottom one. Let's make you orange. Bottom one by negative 3, right? Negative 3 times negative 4 is positive 12. So for sure, the y's will cancel out. So I'm going to double the top. So it's just going to be 14x minus 12y is equal to 16. And the bottom is going to be positive 15x plus 12y is equal to 42. All right, we're going to see, oh, look, the y's cancel out. So we have the x's. 14 plus 15 is 29. X is equal to 58. Divide by 29 on both sides. And we get x is equal to 2. Hey, but we're not done yet because we've got to figure out the y. So here we go. Let's use which one looks okay? Maybe the top. Let's use the top one this time. So we're going to go 7. We know x this time minus 6y is equal to 8. So instead of x, we're going to plug in 2. That's where we got it from. So I get 14 minus 6y is equal to 8. So again, subtract 14 on both sides. Negative 6y is equal to negative 6. Divide by negative 6 on both sides, and y is equal to 1. So our ordered pair is, our solution is 2, 1. Yay! That's system of equations. A lot of algebra, right? Okay, the second thing we're doing instead of systems is also systems, but this is system of inequalities, which we've only learned how to graph it, okay? So let's try these out. Again, we're literally just doing the same thing that we've been doing, except we're just putting 2. We're going to see where they overlap because that's where the solution is. Okay, so again, we're going to start with our y-intercept, which is our negative 1 right here. So negative 1. Our slope is negative 1 over 1. So again, it's a negative slope. Continue the pattern. And is it going to be solid or dotted? It has no equal to sign, so we know for sure that it is a dashed line. I like to say dotted line, but you know, that's actually not a dotted line, it's a dashed line. Okay, again, going all the way across. And this time, instead of actually shading, I'm going to just draw arrows. So it says y is greater than the line that we just drew. So we know that it's going to be this, we're shading on this side. So far, so good. We're going to use the second one. We know we're starting at 3. And our slope, again, is 1 over 1. It is positive this time, so we're going to go up and to the right. All right. And it is going to be a solid line because of that equal sign. Just going to draw that line like this. So it says y is less than the line. So the less than is going to be down here below. So I'm going to be like, I need a shade down here below. So if you notice, where's everything pointing to? Let me just restate that. Do you see how there's an X there, right? And basically we just cut up the whole coordinates plane into 4 sections, right? We have section, you don't need to number these, I'm just showing you. We have section 1, 2, 3, and 4. And notice nothing is pointing to section 4. But where are both of them pointing to? Right? This is section 2 right here, right? So that is what we're going to have to shade. So this section 2 right here is what we're shading. You're only shading one section. You are not shading 2 because it can't meet both criteria. The section 2 is the only one that fits both criteria of being lower than the pink line and above the blue line. And this is the only place where it happens. Okay, done. We're going to do the same thing with 70. We are going to, there's negative 3 right there. Our slope is positive 1. Right? If there's no number, it's a positive 1. It is going to be a dashed line because of there's no equal to sign underneath. There we go. And our other one is going to be, again, our +1. And then we have a negative slope right here, right? So it's going to be up and to the left one. So it's going to go decreasing. And it is going to be a solid line because there's that equal sign under it. But you know what I forgot to do is the arrows. Oops. We can do it with the pink one. It says y is greater than the line. If it's greater than, that's going to be all these numbers up here. So it's going to be above the line. So, okay, one of those places. And then we also know for the blue one, this is y is greater than the line. So again, it's going to be above the line because that's where all the y values are greater than. And what do you notice? What region is it all pointing to? If you said this upper region right here, you would be absolutely correct. Yay! Done. All right, number 71. Again, we're going to go up +1 on the y-axis. We're going to go up 4 and to the left because it is a negative slope. And it is going to be, what is it, dashed line. And it says y is greater than the line. So do you see how this is above? So this is the y is bigger than. And then if you notice right here for the second one is -2. Going to go over to -2. And it's going to be a negative slope. So it's going to be up 1 to the left 1. Up 1 to the left 1. Just like this. But on the other side. And it is also going to be a dashed line because there's no equal to sign. And this one it says y is less than. So we know it's going to be less than this line. So the only place where that fits is, if you notice, it has to be to the right of this blue and below the pink. It's literally this little section right here. That's it. This is all we got. Okay, there we go. Done. Number 72. Oh, I wrote too much. Let's try that again. So slowly resume. Oh, I have to go a lot more. There we go. Let me actually put in the number. There we go. 72. All right. Let's go orange this time. And again, we're going to go +3. So we're going to add 3 right here, or +3. 3 on the y-axis and the slope of 1/3. So up 1 to the right 3, or down 1 to the left 3. And it is going to be dashed line. All right, dashed line. And it says y is less than the line, which is definitely lower than the line. That's where all the y's are. And then we're going to go, second line is going to be -2. And our slope is -4/3. So it's 1, 2, 3, 4 up, and then 3 to the left. Oh, we can't do it the other way. So here it is. And that's going to be a solid line. So we're just going to pretend it went through the -2. And it says y is greater than. So we're going to be shading above the line. Just like that. And do you see where everything is pointing to? That's where we're shading. So we're going to shade that like this. Maybe I shouldn't make it orange. I'll make it blue this time. I want to go over the line. Okay, there we go. Coloring time. All right, same thing here, except we have, again, standard form. So all we're going to do is we're going to convert it to slope-intercept form and then graph it, just like how we've been doing for the last 4 problems. So it's just that added step right there. So here, the first one, it's x minus 2y is greater than -4. So we're going to just subtract x on both sides. And we have negative 2y is greater than negative x minus 4. Remember, they are not like terms. We cannot add them together. And then we're going to divide by negative 2 for everything. And then we get y is, again, we divided by negative numbers, so we have to flip the inequality. So we're going to flip it. This is a 1 up on top, so it's just going to be 1 over 2 x, and that's going to be plus 2. If you don't know why, think about it. Negative divided by negative. All right, so here we go. We got plus 2 right here, and a slope of 1/2. It's a positive slope, so it's going to be up 1 to the right 2. Don't get that confused. The top number is always the up and down part, right? And then it is going to be a dashed line, so we're just going to be like here, dashed line. Perfect. And okay, it says y is less than the line, so we know it's going to be below somewhere here. All right, let's do the second one. The second one, I'm going to be like right there. We got 2x minus y is less than 1. First step, subtract 2x. All right, and then we have negative y is less than negative 2x plus 1. And we just need to get rid of that negative, so we're just going to divide by negative 1 for everything. When we do that, what we get is y. Again, we've got to flip the inequality, so it's greater than. This is going to be just positive 2x minus 1. So again, we're going to go to minus 1 or negative 1, and then up 2 to the right 1, because it is a positive slope. And it is going to be a dashed line because it is not equal to. And it says y is greater than, so we know that it's going to be bigger, like higher, above. And so the only place that works for all of that is right here in this region. Just like that. All right. And we got 74. We got 3 more of these kind of problems. So let's figure it out. Okay. Oh, I like it. Let's try that for the first one. We got x minus 2y. Literally, it's the same. You know what? I'll just do it for the people who did not look at 73. Right? It's literally 73. So we're going to subtract x on both sides. And then we have negative 2y is greater than or equal to negative x plus 4. And then we're going to divide by negative 2 on all 3 terms or all 3 parts. And we got y is, again, we divided by negative, so we got to flip the inequality. We got 1/2 x minus 2. So again, we're going to go to minus 2. I guess it's slightly different because this one was a plus 2 and now this is a minus 2. But anyways, 1/2, so up 1 to the right 2. And this one is going to be a solid line instead of a dashed line. Again. Okay, as good as it's going to get. And it says y is less than that. So we know it's going to be smaller than the line. All right, and then we're going to go to the second one. I'm going to just write it here. So we got 2x minus y is less than or equal to negative 1. And so we're going to subtract 2x on both sides. And you get negative y is less than or equal to negative 2x minus 1. And then we're just going to divide by a negative 1 to get rid of the negative. And we get y is equal to, or not y is equal to, y is greater than or equal to 2x plus 1. All right, so we're going to just go up to 1 right here. And we're going to be like 2, so it's up 2 over 1. Down 2 over 1. And it is definitely going to be a solid line. It has an equal to sign. And then it says y is greater than the line, so we're going to be like greater than the line. That was a weird arrow. Oh, above this pink line and below the blue line, the only place available for that is literally this little section right here. But if we were to expand it out, it would just literally be huge. All right. Okay, these are our last two for day 3. We got this. We can do it. All right, so for the first one, we have 2x minus y is greater than 1. So we're going to subtract 2x on both sides. And we have negative y is greater than negative 2x plus 1. And we're going to divide by negative 1. Everything divide by negative 1. And we get y is, again, we got to flip it because we are dividing by a negative. If it wasn't negative, we would be fine. And that would be 2x minus 1. So here's minus 1. We're going to go up 2 and to the right 1. Down 2 to the left 1. Again, that is going to be a dashed line. So you go all the way across. We got to see, okay, y is less than, so it's going to be below the line. So somewhere over on this side. And then we're going to do the second equation, or inequality, 2x minus y is less than or equal to, where are the all minuses? If it was a plus, it would have made our life so much easier, but that's fine. Who chose these questions? I'm sorry, it was me. I'm sorry. Okay, here we go. We're going to subtract 2x on both sides. And we get negative y is less than or equal to negative 2x plus 2. And then we're going to divide by negative 1 so that we have a positive y. And you just need to scoot down just a little bit, just a smidgen. We have y, again, we got to flip our inequality, 2x minus 2. We're going to go to minus 2, and we're going to go up 2 to the right 1, up 2 to the right 1. Or do you see this? This is like our, what is it called? Parallel lines, right? This is going to be, again, a solid line. It says equal to. But this is not a no solution because it is inequalities. So again, it says it's going to be above this line. So if it's going to be above this pink line but below the blue line, then you know where the solutions are. Literally, it's going to be right in between. It's technically right in between. That is a shaded area, just like that, like a little sliver. Okay, and then 76, last problem for day 3. We're getting close, guys. So we got 3x minus y is less than 3. Again, we're going to just subtract 3x on both sides. Get y by itself. And we got negative 3x plus 3. And we're going to divide by 1 for everything. Y, again, I'm sorry. I don't know why they're all divided by negatives. Yeah. Anyways, we're going to flip it. And negative 3 divided by 1 is just going to be positive 3x minus 3. And so we're going to go over to minus 3. Go up 3 over 1. This is going to be a dashed line. Just like that. And we're going to do the second one. This is x minus 2y is greater than or equal to negative 4. And we're going to just subtract x on both sides. Again, if you keep on doing this, your brain will get it. It will get it, I promise. You just got to keep on practicing it. And divide by negative 2. And so y, again, we are dividing by negative. So we're going to less than or equal to 1/2 x. That's negative 4 divided by negative 2, so it's positive 2. So we're going to go to positive 2, and it's the slope of 1/2. And it is a solid line. Ooh, I didn't do the arrows. It says y is less than this orange line, so we know it's going to be somewhere down here. Okay, and for the other one, it says y is greater than, so it's going to be bigger than the line. Do you see where it's all pointing at? Yes, right here. This section is the solution. Okay. All right, congratulations. Oh, look at the answers. Yay. Okay, we are now on to day 4 of 4. This is the last bit. All right, 77. We're simplifying. We're now in exponents. Yay. All right, good. You guys have been doing such a great job. Okay, so again, we're going to be multiplying these guys. And remember what exponents tell you. What do they tell you? Like, it just says, so it's got -2, and we're going to just expand these. We've got 3 a's, so we're going to go a times a times a. Not the -2, because this 3 is not for the -2. If we wanted to include it, we would be like parentheses, but it doesn't have that. So it's just for the a. And then times, we're going to do this again for the second part right here. So this was this part right here. Oh, that was terrible. So this part right here, I'll just underline it. That's going to be -2 times, again, a times a times a. So we got 3 of them. And then we'll do purple. So this 4a is, so it's times 4 times a times a times a times a. You can figure out the shortcut, be my guess, but just make sure it works. I'm not going to tell you the shortcut. I'm just going to show you how to expand it, and then we'll work on it. So again, we're multiplying everything, so we're going to multiply all these numbers first. So -2 times -2 times 4. So -2 times -2 is 4. 4 times 4 is 16. Okay, write that with, like, let's go this color, 16. All right, and so we have a's. We have a whole bunch of a's. How many a's are we multiplying? 1, 2, 3, 4, 5, 6. And then we got 4 more here, so that's 10. Ta-da! We're done. We always have to make sure we have only positive exponents. We have positive exponents, we're fine. All right, next one right here. Again, the coefficient does not matter. That can be negative. Like, we could have had a negative answer, but here we go. So again, we're going to do, here's a 2x. That is just 2 times x, right? And then then we go green. This part right here, so it's times x times x. And last one, it says, right here, it says times negative, what's x to the 0 power? Anything to the 0 power is 1. So we're just going to write it just like that. And we've got 2 times -1, which is -2. And we have x how many times? 3 times that we're multiplying. So it's x to the 3rd power, like that. All right, 79. Ooh, that was too much. Just need a little bit. So 79, we have, again, 3 n's. So this is going to be right here, n times n times n. Did you figure out the shortcut, or are you getting tired of this? Times -4 times how many n's? We got 4 of them. So again, just for our numbers, we only have a -4, so I'm just going to write in the front. How many n's are we multiplying? We have 3 here and 4 here, so together that's 7 n's that we're multiplying. Done. Then 80, let's expand it. We got -2. X to the 0 power is just times 1. And then we have right here, this part is going to be times 2 times, we have 4 x's, so x times x times x times x. So what do we have? -2 times 1 times times 2. It's just going to be -4. How many x's do we have? 4. We're multiplying 4 x's. That's it. Yay. 81, same idea, same concept. We have inside these parentheses, whatever this is inside the parentheses, we have 2 of them, right? So I'm going to just rewrite that. So here, with this 2, we're going to have -3x squared times -3x squared. Why is it 2 times? Because of this little 2 right here. Okay. Now, this looks literally like 79, right? But we just gotta, so if you want to expand it, we can expand it. If you're like, I get it, Miss Lee, we can just write that. So -3 times -3 is going to be +9. You write that with this one. So +9. And if we were to expand this, how many x's would we have? 2. How many x's would we have here? 2. So together we have 4. We have fingers for a reason, people. So x to the 4th. So there we go. Okay, again, we have this. We have 4x. We have going to write that 3 times. So this is going to be 4x times 4x times 4x. So again, like if you look up here, we didn't put 2x times 2x times 2x because there was no parentheses. X is only for the 4. So here we have parentheses, so that's where we're including it 3 times. All right, so we're going to do 4 times 4 times 4, which is going to be 16 times 4, which is 64. How many x's are we multiplying? We got 3 of them, so it's x to the 3rd power, or x cubed. Okay, again, we got this one, same idea. We have 4x, and how many times do we have that? We have that 2 times. All right, so we have 4 times 4, which is 16. And we have how many x's? We got 2. You see the shortcut? If not, that's okay. Again, for 84, we got a to the 3rd power squared. So we have a to the 3rd power times a to the 3rd power. So if we were to expand that, how many a's do we have here? We have 3 a's, a times a times a. On the other one, we have another 3, a times a times a. So together we have 6 a's that we're multiplying. This a to the 6th power. Okay. Ooh, my favorite. Here we go. It's not that way. We're down just a bit. All right, so here we have okay, I'm gonna put the fraction bar here. Okay, on the top, we're doing this separately here. So -3. I know I have 2 m's, so m times m. And m to the 0 power, remember, anything to the 0 power is just 1. Okay, the bottom, we got -2, and we have 4 m's, m times m times m times m. All right, so now what we do know about this fraction bar is that it's dividing, right? So we know m divided by m is just 1. Okay, so we're like, okay, that cancels out to just be 1. That cancels out to just be 1. So we can cancel out 2 of them. We can't cancel out more because we don't have any more m's on the top. So now this is what we have. So what do we have left? Negative divided by negative is positive. So I'm just going to have 3 on top. Because what is 3 times 1? 1. And then we have 2 on the bottom. And how many m's left? 2. So it's m squared. That's it. Hey. We're going to do the same thing here. Again, we're going to expand it. So here's my yellow. Here we got 4 times n times n. And then we have blue. This is blue. Times 3 times n times n times n times n. And then we have orange, which is going to be 4 times n times n. And have their fraction bar just like that. And then on the bottom, we have pink. And we'll be like 4 times n times n times n times n. 4. All right. So now what we're going to do is we're going to just find ones. So n over n, n over n, n over n, n over n. But 4 divided by 4 is also 1. You see what I'm saying? And then so what we're going to do is now we've simplified everything. We literally have nothing left on the bottom. So we have 3 times 4, which is 12. How many n's are we multiplying? 2 here and another 2 here. So that's going to be 4. Nothing on the bottom, so we can just leave it just like that. Okay, 87. this is going to be, again, 4 times, we got 2 n's like this. On the bottom, we have a negative, n to the 0 power is just 1 times negative n. Got it? Can we cancel anything out? Yep, just this one right here. So what do we have left? 4n on top, and negative times negative is going to be positive, so it's just 1 on the bottom. So technically you don't need to write that down, because that does mean 4n over 1. If you do write 4n over 1, it's not wrong. It's just you need to recognize that can be rewritten as 4n. Okay. Last part of this one is going to be 4a times negative 3 times a times a times a. We got 3 of them over negative a. All right. Well, we do know that this negative and this negative makes a positive, and an a cancel out. Oh, I guess I could have canceled that one out. But anyways, doesn't matter. And we got 4 times 3, which is 12. I have 3 of a's, so a to the 3rd power. Nothing left on the bottom, so that's it. If we did have something left on if we didn't have anything left on the top, we would put 1 over whatever that is, but we're fine with that. Okay, now simplifying expressions. Okay, so again, we're starting with the highest exponent, and then we're going to combine the ones that have the same exponents together. Remember, the exponents are the little numbers here. All right, so I see here we have this a to the 5th power. We don't have any other a to the 5th power, so I'm just going to copy that down. And then I know the next biggest exponent is going to be this a to the 3rd power. So I'm going to be like minus 7a to the 3rd power. This is minus 4 minus 3, so it's minus 7. Okay, and then the last thing that I see here is this minus 3 and 7. 7 minus 3 is positive 4. Right? Do you see how they're all in order? They're already dead. All right, number 90. Look, we're already at 90 peoples. Okay, again, we're going to highest exponent. I got negative 8x to the 5th power plus 7x to the 5th power, which gives me negative x to the 5th power. If you write down negative 1x to the 5th power, it's not wrong. It's just, we don't usually write it that way. So we got our 6x, and we have another x right here. So 6 plus 8 is going to be plus 14x. Remember, we always look in front, not behind, okay? The behind has nothing to do with this 8x. It's just what we're going to do anyways. And then the last thing we have right here, the only thing we did not address is this minus 3. We're just going to be minus 3. That's our answer. 91. I'm just going to do it like this. So again, I'm looking for the highest exponent. I got 4p to the 4th power plus 5p to the 4th power. So it's going to be 9p to the 4th power. And then the next one, p to the 3rd power. So I got plus 7p to the 3rd power. So I don't got any of that other stuff left. Got minus 8 is minus 16. All right, and again, our highest exponent is going to be this 3 right here. 6 minus 3 is going to be 3a cubed. And then we got, an a squared. We got 2a squared, which is going to be plus 2a squared. And we have plus 3a minus 6a is going to be minus 3a. Simplify each expression. Done. All right, it says find each product. This is number 93. So I've been showing you guys what is it called? The box method, the area method. Okay, and I know it's a 2 by 2 because each of these have 2 terms in it. So the left one I'm going to put right here, 8n plus 8. And here we have 5n plus 8. Okay, I'm going to just highlight so you can see where we got that from. And this is right here. All right, so now all we're going to do is just multiply. Here we're finding the area. It's just literally length times width. All right, so 8n times 5n is going to be 40n squared. Since we have 2 n's that we're multiplying, it would be n squared. And I'm just going to go across. So 8n times 8 is going to be 64n. We only have one n this time because there's no n here, right, for the 8. 5 times 5n times 8 is going to be 40n. And 8 times 8 is going to be 64. So I'm not leaving it like this. This is just a way for me to remember what to multiply, right? And I'm going to just, again, just like how we did before, we're going to, like in problem 92, we're going to just combine like terms. So 40n squared is, we don't have any other n squares. 64 plus 40 is going to be 104n plus 64. Done. There we go. All right, we're going to do the same thing for the next one. Don't make your boxes too small. You have so much room, right? So we got 5p minus 6, and then 8p minus 7. All right, and we're going to just multiply the insides, multiply to get the insides. So 5p times 8p is going to be 40p squared. 5p times negative 7 is negative 35p. Negative 6 times 8p is negative 48p. And negative 6 times negative 7 is going to be positive 42. And we're going to write our answer diagonal. So this is going to be negative 83p plus 42. Done. All right. And so, okay, there we go. Again, we're going to do the same. This time I'm going to show you the FOIL method. If that strikes your fancy, some of you guys were already doing that. 3x times 6x is going to be 18x squared. Just literally doing distribution. 3x times negative 2 is going to be minus 6x. All right, and we got negative 4 times 6x is going to be negative 24x. And negative 4 times negative 2 is going to be plus 8. All right, and if we notice right here, we have our two like terms right here. So our answer is going to be 18x squared. This is going to be minus 30x plus 8. Okay. The reason why I don't introduce you like this first is because a lot of people just forget the middle parts and they just do the ends. That's all. I don't know why, but people forget it. So again, it's just distribution. We're going to take 7v times 7v. So that's going to be 49v squared. 7v times minus 7 is going to be minus 49v. And we have negative 4 times 7v is going to be minus 28v. Negative 4 times negative 7 is going to be plus 28. So again, we're going to combine like terms. So we have 49v squared minus 77v plus 28. All right, there we go. Yay. Okay. Oh, see, there's the answer for 96. All right, we are so close to being done. It says simplify. So we have radicals. We're just going to simplify them. We're going to just use a factor tree and to help us do a prime factorization. So what two numbers multiply to 28? And in my head, like 4 and 7. 4 times 7 is 28. I can break down the 4 into 2 times 2. I cannot break down the 2 because it's a prime number. I can just only break it down to 2 and 1. But anytime you get to 2 and 1, you already know you have a prime number. So same thing with 7. The only way to get a 7 is 1 and 7, 1 times 7, right? So I'm all down to prime numbers. So I'm going to rewrite the 28 to look like 2 times 2 times 7. I always put my double repeated numbers in front. This makes it easier for me later on. So I do have my pairs. So that's going to be the square root of 4, right? 2 times 2 is 4. And I have my single guy right here. Oh, it doesn't have to be a guy, I suppose. All right, so that's going to be the square root of 7. And then I have to ask myself, well, what's the square root of 4? What two numbers when you what number when you multiply it by itself will give you a 4? 2. That's literally how we got it, right? So it's going to be 2, no square root, because it's just 2. Root 7. Simplified. Done. We call it simplified because there are no more perfect squares in there. So here we go. Let's take out some perfect squares for this guy. We know it's going to be 4 times 12. I can break down the 4 by 2 and 2. I can break down the 12 by 3 and 4. 3 times 4 is 12. I know that I can break down the 4 with 2 times 2. So all these little, see how they have no more like numbers coming out of it? That's what goes in here. So square root of 48 is the same thing as 2 times 2 times 2 times 2. 2 times 3. I have 4 2's and a 3. Okay, again, I'm going to look for my pairs. I got a pair here, so that would be a square root of 4. I got another pair right here, which is going to be the square root of 4. And I have my lone wolf right here, so that's square root of 3. And the square root of 4 is just going to be, let's see if we're going to use this. Square root of 4 is just 2. And the square root of 4 is still 2. And then we got the square root of 3. Right? And we know that 2 times 2 is 4. So it's just going to be 4 root 3. Yeah. Ooh, 512. Let's try. I know I can divide it by 4, or 2. I'll just say 4. Okay, 4 goes into 5 one time, remainder 1. You can use your calculator. I don't have a calculator right now. 4 goes into 11 like 3 times. No, 2 times. 8. Remainder 3, and that's going to be 8. 4 goes into 32 8 times. Okay. Where's that guy? All right, so I can break up the 4 into 2 and 2. I can break up the 128. That also goes into 4, so 4 times 32 is 128. So 4 is, again, can be broken down to 2 and 2. 32 can be broken, this is a lot of 2's. 32 can be broken down into 4 and 8. 4, again, 2 and 2. 8, do not say 4 and 4, because it's not 4 times 4 is 8. So it's 2 times 4. And I'm going to be like 2 times 2. All right. How many 2's do we have? We have like a whole bunch of 2's going on. We have, let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So literally 1, no, I wrote down 9. Oh dear. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I got a pair here, so that's square root of 4. Got another pair here, that's again square root of 4. Got another one here, that's the square root of 4. And I have another one here, that's the square root of 4. My lonely guy right here is going to be square root of 2. All right, so what is the square root of 4? And the square root of 4 is just 2. Again, this is going to be 2. And this is going to be 2. This is a lot. And then we have our square root of 2 because that did not have a that did not have a match. Did not have a pair. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is going to be 16 root 2. Okay, last of these simplifying radicals. How do we get to 252? I know 2 goes in there for sure. 2 goes into 2 once, twice, and 6. 126, I know 2 goes in there for sure. And I'm going to be like, that's going to be 6 and 3. 63, I can do 9 and 7. 9 times 7 is 63, and 9 is going to be 3 times 3. All right, so I have all of my 2 on 2, 2 times 2. I also have 2 3's, so 3 times 3, and I have a 7 times 7. So again, square root of 2 is, 2 times 2 is square root of 4. And this is going to be square root of 9. And our lonesome is going to be square root of 7. That's this guy right here. Okay, so square root of 4 is just 2. Square root of 9 is 3, because 3 times 3 is 9. And we have our square root of 7. Okay, 2 times 3 is 6, root 7. Done. So square root of 252 is the same thing as 6 square root of 7. Okay, this is the last 4 questions. We made it to the end, guys. So we're just going to factor completely. So again, how do we get 5v squared? We're just going to go 5v times v. Two numbers that multiply to 56, 7 and 8. Let's put 7 on the top, 8 on the bottom. Well, let's find out. Let's see if it works. V times 7 is 7v. 5v times 8 is 40v. And the only way to get 33 is if positive 33v is if the 7 is negative. Right, so that will give me a 33v, because negative 7 plus 40 is going to be 33. So that is the same. So yay. And then check mark for that. So again, we're going to go straight across. Remember, we used yellow and pink, right? In class time. This is the part that's going to mess people up if you don't do this. So remember, going straight across, so it's 5v minus 7 times v plus 8. All right? That's it. Factored. Done. If we were to multiply this back out again, like what we did a couple times before, we'll get back to this answer right here. Again, 3x squared, we got 3x and x. Only way to, oh, there's a lot of ways to get 36. Let's try 6, 9, and 3. 9 and 3. So 3 times 9. So x times 3 is 3x. 3 times 9 is going to be 27x. Ooh, that gives me a 30, though. That's not going to work. Let me try. Not 9 and 3. It's going to be... Oh, because it was not 9 and 3. It's 9 and 4. That's 36. Sorry, it's getting a little late for me. 9 and 4. 9 times 4 is 36. 9 times 3 is 27. Do this. So 4x, and this is going to be 27x. There we go. So if we add these guys, it's just going to give me 31x. Okay, no negatives here. And so again, we're going to go straight across. And we're going to have 3x plus 4 times x plus 9. Okay, that was not good. 9. There we go. Got my plus. Okay, last 2 questions. Here we go. We got 7m and m. And we got, we want to get to 65. So 9 and 2. So I got 2 and then the 9 so that I can multiply with the 7. So 2m is equal to 63m. And both of them, we want to be negative 65. So both of them would have to be negative. So put those negatives, so that'd be negative 65m, which is, yay, good job. So again, we're going straight across. And we got 7m minus 2 times m minus 9. Right, last question, guys. 7k squared, we got 7k and k. And this is going to be 2 and 5. Ooh, 1 and 10. You don't usually see a 1 and a 10, but we got k and we got 70k right here. And we want a positive 69, so we know that the k has to be negative. There we go. And that would give us a 69k, which is, yes, same as that middle number right there. So again, we're going straight across. And we got 7k minus 1, k plus 10. Answers. Yay! Good job, guys. We did it, made it to the end. This is all that's going to be on the final. All right. Have a good one, guys. Keep practicing. You guys got this.